The name alone carries a strange charge. Three-Eye Atlas. For most people, it's little more than a mysterious string of characters, the kind of shorthand usually confined to scientific reports and obscure databases. Yet behind this technical label hides an object that has already stirred imaginations and anxieties alike. Three-Eye Atlas is not just a rock wandering through space. It is an interstellar visitor, one of the rare bodies confirmed to have entered our solar system from beyond. To some, this might sound like little more than trivia, the kind of fact that slips across a science news feed before vanishing again into obscurity. But every now and then, an astronomical discovery tugs at something deeper, a chord that resonates not only with specialists, but with the rest of us. This is one of those moments. The reason is simple: trajectory. Unlike planets, which follow stable and predictable orbits, or comets, which cycle in and out of the inner solar system, Three-Eye Atlas is on a hyperbolic path. It does not belong here, and it will not stay. Its passage is brief, a cosmic encounter that reminds us of the sheer openness of the heavens. But the precise line it carves through space has raised eyebrows. Observations suggest that it is moving in such a way that it will sweep inward, closer and closer to the sun. That fact alone can trigger a cascade of questions. If something from beyond our stellar neighborhood hurtles toward the furnace at the center, should we be worried? Could such an object unleash consequences, either through physical interaction or through subtler dynamics that ripple across the solar system? At first glance, the answers seem reassuring. The sun is enormous, a gravitational well so deep that nothing as small as an interstellar fragment could possibly disturb it. Stars are not fragile. They are roaring engines of plasma, burning for billions of years, indifferent to dust and rock. But reassurance is rarely the end of the story. As we dig deeper, a more complex picture emerges. One in which scale and unpredictability interlace, in which cosmic events are not only about energy and matter, but also about perspective, about the fragile line between awe and alarm. To understand the stakes, we need to step back and look at how our minds interpret risk. Humans are not naturally wired to think in terms of astronomical distances or eons. Our sense of danger comes from immediate threats, storms, predators, social tensions. When we hear that something is approaching the sun, our intuition reaches for metaphors. Fire spreads, objects falling into flames cause explosions. Even the most distant conflagration feels unsafe. These instincts shape the way headlines are written and the way conversations unfold. Suddenly, Three-Eye Atlas is not merely a speck gliding across charts, but a character in a story, one where proximity to the sun becomes a dramatic turning point. But it's not only about narrative. Scientists, too, have reasons to pay close attention. Every interstellar visitor is a messenger, carrying with it material forged in an alien environment. The grains of dust that coat its surface, the gases that might outgas as it warms, the very structure of its orbit. All of these are precious clues about what lies beyond the heliopause. Each passage is a once-in-a-lifetime laboratory, a fleeting opportunity to peer into the chemical and dynamical processes of other star systems. That sense of rarity amplifies the tension. We are not just watching an event, we are scrambling to collect as much information as possible before the moment slips away. And so a paradox arises. On one hand, the sober conclusion remains that the sun itself faces no risk from an interstellar visitor like Three-Eye Atlas. On the other hand, our species feels compelled to dramatize the encounter, to imagine worst-case scenarios, to inflate the encounter into a symbolic test of cosmic stability. These dual responses, scientific precision and human imagination, collide in public discourse, creating a fertile ground for both discovery and fear. What emerges, then, is not only a question of astronomy, but of psychology. The thought of Three-Eye Atlas diving toward the sun resonates because it mirrors the archetype of sacrifice, of a small thing surrendering itself to a larger force. Yet in that act of approach lies uncertainty. Will it disintegrate quietly, scattering into dust that the solar wind carries away? Or will it flare, briefly visible to the naked eye, a streak of light across dawn skies? Could it even, in some as yet unexpected twist, alter the environment around our star in ways we have not anticipated? Even asking such questions hints at the broader theme. Our constant attempt to balance knowledge and wonder, to find equilibrium between data and myth. This is the terrain where we must situate Three-Eye Atlas, not as a harbinger of doom, nor as a trivial curiosity, but as a phenomenon that touches both science and culture. The journey ahead, as we follow this object toward the sun, will demand that we stretch our understanding of physics while acknowledging the pull of metaphor. It will ask us to examine how much we really know about stellar dynamics, and how much of our response is shaped by narratives that predate modern science. Most of all, it will force us to reconsider what it means to share space not only with familiar planets and comets, but also with visitors from far-off systems whose paths intersect ours only once. As the story unfolds, the tension will not come from the likelihood of catastrophe, but from the complexity of meaning. For now, the question remains: when something foreign edges closer to the blazing core of our system, what exactly are we watching? A scientific event, a mythic performance, or both? And what new questions will that collision of perspectives set into motion as Three-Eye Atlas continues its descent? To make sense of what Three-Eye Atlas actually is, we need to build a framework that distinguishes it from the many other objects constantly in motion around our sun. Every year, thousands of comets and asteroids are catalogued. Some are mere flecks of rock, barely detectable against the blackness. Others are mountain-sized bodies whose trajectories are mapped decades into the future to assess any potential intersection with Earth. Within this population, the line between ordinary and extraordinary lies not in size, shape, or even brightness, but in origin. Most of the familiar travelers belong to the solar system's own extended family, formed from the same disk of dust and gas that condensed into planets. They are, in a sense, local debris, fragments left over from the system's turbulent youth. Three-Eye Atlas does not belong to this family. Its designation tells us that much. The 3-eye stands for Third Interstellar, marking it as only the third object confirmed to come from beyond the Sun's gravitational dominion. The first, Oumuamua, appeared in 2017, a cigar-shaped mystery that streaked through the inner solar system before vanishing. The second, Comet Borisov, was discovered in 2019, unmistakably cometary with a tail of dust and gas. Atlas follows in their wake, another emissary from deep space, another data point in a growing realization. Interstellar objects are not mythical rarities, but actual participants in our cosmic environment. Their arrival is a reminder that the solar system is not sealed. It breathes, exchanges matter, and occasionally receives visitors from faraway neighborhoods. From the perspective of celestial mechanics, what distinguishes such a body is its hyperbolic orbit, whereas asteroids and comets bound to the Sun trace ellipses, sometimes elongated but always closed. An interstellar traveler plots a curve that never loops back. Its velocity is too high, its path too open. Even as the Sun bends its trajectory, it cannot capture the object permanently. It arrives, swings close, and departs for good. This one-time passage makes each encounter precious. Once lost to the outer dark, the same object will never return within human timescales. But the notion of a visit carries with it more than technical significance. It forces us to broaden our definition of what the solar system is. For centuries, astronomers imagined our planetary system as a self-contained stage. Then came the discovery of exoplanets, showing that stars everywhere host companions. Interstellar objects take the concept further, demonstrating that pieces of other systems can actually cross into ours. In a sense, 3i Atlas is both alien and intimate, bridging the gap between stellar neighborhoods by physically entering ours. Here is where context matters. The Sun itself, a star among billions, drifts through the Milky Way with its retinue of planets. Every few million years it passes through different regions of interstellar space, encountering clouds of gas, stellar associations, and perhaps swarms of wandering debris. Occasionally, gravitational nudges send fragments tumbling into our path. These fragments might have formed around stars long extinguished, or in nebulae far older than our own system. Each carries with it a record of environments we can scarcely imagine. When we study the spectra of light reflected off 3i Atlas, or analyze the gases it may release, we are in effect sampling another solar system without leaving home. And yet, with this marvel comes a subtle unease. We are conditioned to think of the solar system as ordered, planets in steady circuits, comets in expected arcs, moons faithfully trailing. A foreign object disrupts this picture. Its arrival feels unscripted. A reminder that space is not a clockwork, but a shifting sea. Even if no danger is present, the idea of something uninvited stirring through the inner regions triggers both wonder and caution. It is this duality, cosmic openness and human wariness, that shapes our reaction to the approach of 3i Atlas. The next layer of the framework concerns the Sun itself, the destination toward which Atlas is drifting. To understand why anyone might feel apprehension, we must appreciate what the Sun represents, a 1.4 million kilometer sphere of plasma, generating energy through nuclear fusion at its core, radiating heat and light across the solar system. Everything about it dwarfs an interstellar fragment. Its mass is so great that it accounts for 99.8% of the solar system's total. Against such immensity, a body a few kilometers wide is negligible. Yet paradoxically, the very act of moving toward the Sun sparks anxiety. Perhaps it is because the Sun is not just another celestial body, it is the source of our existence. The thought of it being struck or interfered with, however irrational, unsettles us on a symbolic level. This is why building a precise conceptual scaffold is essential. Without it, imagination races unchecked, turning the arrival of Atlas into a tale of catastrophe. With it, we can separate fact from metaphor, science from instinct. We can say clearly, the Sun will not be harmed by an object like this, but we can also admit the significance lies not in solar danger, but in the opportunity to learn, in the chance to glimpse matter forged far away. As we settle this basic frame, one question rises naturally. If the Sun is safe, and if the object itself is too small to cause upheaval, then why does the trajectory matter at all? Why should its inward path toward the stellar furnace capture attention? The answer lies in connections not immediately obvious. How objects approaching the Sun change state, how their material interacts with light, and how those fleeting transformations become our only window into their alien makeup. The closer 3i Atlas gets, the more it reveals of itself. And so, the framework is not merely about categories, local versus interstellar, bound versus unbound. It is also about dynamics. What happens when heat, radiation, and gravity work upon something that has never felt their touch before? In that drama, there is no threat to the Sun, but there is something equally compelling, the possibility of revelation. The stage is set, the roles clarified. Now the chain of causes and consequences begins to take shape, and with it, the deeper question of why this fleeting passage demands our close attention. Causality is the backbone of scientific thought, the thread that connects observation to understanding. If we are to move beyond the bare fact that 3i Atlas is moving sunward, we must follow the trail of causes and consequences that shape its journey. The story begins far from here, in a place we will never visit directly. Somewhere beyond the sun's sphere of influence, perhaps in the scattered debris of a distant stellar nursery, this object formed. It may have been a fragment chipped away by collision, or a leftover shard from the early accretion of planets around another star. Gravitational encounters, close brushes with giant worlds, or perhaps with the star itself, would have flung it out of its home system, exiling it to interstellar space. From there, the cause and effect chain became more diffuse. For millions or even billions of years, it drifted through the galaxy, bound to no star, a dark traveler pulled only by the faint tides of distant gravities. Eventually, its path intersected with the moving bubble that is our solar system. The sun, tugging on everything with its immense gravitational reach, altered the trajectory of 3I Atlas. A delicate interplay of velocity and angle determined that it would not merely graze the outskirts, but pass closer, threading its way inward. This is not fate in the mystical sense, but mechanics, a precise calculation of mass, momentum, and trajectory. The causes are invisible to us, but they accumulate into inevitability. The next step in the chain is interaction with solar energy. As Atlas approaches, sunlight begins to do what no starlight in the deep void could achieve: heat its surface. For an icy body, this means sublimation, ice transforming directly into gas, carrying with it dust grains that scatter light and form a cometary coma. For a rocky fragment, it means thermal stress, fractures, the possibility of disintegration. These processes, while seemingly small, have outsized consequences for us. They turn the object from invisible stone into an observable phenomenon. Without the sun's heat, Atlas might remain dark, slipping unnoticed across our telescopes. With it, it can bloom into visibility, allowing us to study composition, albedo, and behavior. Here lies the irony. The very cause that might lead to the object's destruction, solar heating, is the same that makes it scientifically valuable. The closer it comes, the more it reveals. Dust clouds betray mineral content. Outgassed molecules leave spectral fingerprints. The curve of its trajectory under solar pull allows astronomers to refine models of its mass and density. Each causal step, from ejection out of a foreign system to thermal breakdown near our own star, produces an effect that we can record and interpret. But causality also runs in reverse in our minds. The fact that an alien object is approaching the sun triggers speculation. What effect might that cause? We begin to imagine disruptions, chain reactions, unanticipated outcomes. Even though the object's mass is negligible compared to the sun's, we wonder whether a solar flare might be provoked, whether magnetic fields might be stirred. In reality, such effects are vanishingly unlikely. Yet the causal imagination does not obey probability, it obeys narrative. We are drawn to lines of reasoning that connect one event to another regardless of scale. This interplay between physical cause and psychological cause is key. Physically, the sun dwarfs Atlas so completely that the causal influence flows one way. The star determines the fate of the visitor. Psychologically, however, the presence of the visitor causes ripples in us. It awakens our fears, prompts our curiosity, reshapes our sense of cosmic security. The arrival of Atlas is not just an astronomical event, but a cause of cultural discourse, of myth-making, of scientific mobilization. It is important, too, to notice the asymmetry of scale. One tiny rock can cause an outsized effect on human imagination, while having almost no effect on the sun. This mismatch is itself a reminder of how causality depends on context. For the solar system, Atlas is a negligible perturbation. For science, it is a rare experiment. For the human psyche, it is a symbol of intrusion, of the boundary between familiar and foreign being crossed. Tracing these causal threads helps dissolve confusion. We can say with confidence that the sun will not erupt because of Atlas, that causal link does not exist. But we can also affirm that Atlas will disintegrate or flare precisely because of the sun. That cause is inevitable. In a chain of events spanning stellar birth, galactic drift, gravitational capture, and solar encounter, the sun is the final agent, the last domino that tips the visitor into transformation. And yet, as clear as these links appear, there is a gap in the sequence. We know the cause, we anticipate the effect, but the precise pathway remains uncertain. Will Atlas fragment spectacularly, leaving a tail across our skies? Will it fizzle, breaking down too quickly to notice? Will it surprise us, resisting disintegration longer than expected? Each possibility carries implications for how we interpret the physics at play. The cause may be fixed, but the outcome is still shrouded. This tension between determinism and unpredictability drives us onward. We crave to know not just the general arc, but the specific unfolding. Causality, after all, is not only about linking past to present, but about projecting into the future. And it is here, at the boundary between what must happen and what might happen, that the approach of Three-Eye Atlas compels us to imagine scenarios that extend beyond ordinary expectation. For if the sun cannot be harmed, what about us? Observers on a planet that lives by its light, interpreters of every celestial change as a potential sign. The chain of causes leads not only outward into astrophysics, but inward into the structures of our own perception. What if the chain of causes had bent differently? Imagine for a moment that Three-Eye Atlas had not been deflected into a path grazing close to the sun, but instead altered just enough to sweep nearer to Earth. The same gravitational nudges that cast it inward could have set its course a fraction of a degree aside. A small adjustment amplified over astronomical distances until its target became not the central star, but a planet orbiting 150 million kilometers away. The mathematics of celestial mechanics leaves plenty of room for such counterfactuals. A body ejected from another star system could in principle collide with ours. And though the probability is vanishingly small, the imagination rushes in to fill that gap. Consider what it would mean. An interstellar impact is unlike any we have recorded in human history. The Chicxulub asteroid that doomed the dinosaurs was local, born within the sun's sphere of influence. Its composition was familiar, its chemistry reflective of our neighborhood. Atlas, by contrast, might carry isotopic ratios not seen here, minerals forged under alien pressures, organic molecules shaped by a different star's radiation. The collision would not only devastate the surface, but also deliver information, data, in the form of catastrophe. We would inherit a new layer of the cosmos, imprinted in the very rock that fell upon us. The irony is brutal, knowledge gained through destruction. Now shift the scenario slightly. Suppose Atlas were larger, not a fragment, but a minor world, 100 kilometers across. Its passage toward the sun would release not a wisp of gas, but a torrent, a massive outgassing that could brighten it into a celestial spectacle visible for weeks. In this counterfactual, the public conversation would not be about, is it dangerous to the sun, but is it dangerous to us? Solar heating of such a body could create debris fields crossing planetary orbits. Earth might find itself intersecting the trails of dust, leading to storms of meteors or even larger impacts. The drama of the sky would be matched by the anxiety of vulnerability. Push the speculation further still. Imagine that Atlas, instead of a natural fragment, were artificial, an engineered probe flung deliberately from another star system. The counterfactual leaps into the realm of science fiction, but it serves a purpose, to reveal the assumptions behind our real interpretations. If Atlas were artificial, every fragment of data, its reflectivity, its acceleration, its disintegration, would be reread as a message. Its plunge toward the sun would appear intentional, a sacrificial act of delivery. The sun would become not just a furnace, but a stage for interstellar communication. The fact that we do not treat Atlas this way demonstrates the gravitational pull of our default belief, that it is natural, unintentional, a wanderer without purpose. Counterfactuals shine light on such hidden premises. Even within the natural domain, counterfactual thinking alters our sense of risk. The actual Atlas poses no threat to the sun, but the counterfactual Atlas, larger, closer, faster, becomes a thought experiment in planetary defense, in how we would respond to the sudden discovery of something both alien and inbound. Would we unite resources to divert it? Could we even attempt such a feat with so little warning? And would the knowledge that it came from beyond our system change the calculus, making us more eager to preserve it for study rather than destroy it for safety? The tension between curiosity and survival comes to the surface only when we imagine the what if. There is another counterfactual worth considering. What if Atlas had remained invisible? If its trajectory carried it near the sun, but it never brightened, never revealed itself to our instruments, the story would be lost. Countless other interstellar fragments may have already passed unnoticed, their histories erased in a flash of sublimation. Only the rare combination of size, surface composition, and observational luck brings such objects into our awareness. This alternate history, one in which Atlas slipped through unseen, reminds us that our knowledge of the cosmos is stitched from accidents as much as from certainties. Such exercises in imagination are not idle. They prepare the mind for real possibilities, however remote. They sharpen our grasp of scale and consequence. By asking what if Atlas struck Earth, we clarify why its actual trajectory is harmless. By imagining what if Atlas were enormous, we understand the significance of its modest size. By picturing what if Atlas were a probe, we test the boundaries of our interpretations. Counterfactuals are laboratories of thought, running experiments impossible in reality but illuminating in logic. And yet, in playing out these alternate scenarios, we arrive at an unsettling awareness. The cosmos contains every variation somewhere. What is impossible for Atlas may be inevitable for some other fragment in some other epoch. Interstellar impacts must have occurred in planetary histories. Engineered probes might someday be launched by civilizations we have not yet met. Each counterfactual is a shadow cast by an actual event, somewhere, sometime. To think them through is to glimpse the full spread of possibility in a galaxy that never runs short of time or material. As 3i Atlas continues its real journey toward the sun, our counterfactuals dissolve back into speculation. But the habit they awaken remains. We begin to sense the fragility of our position, not because Atlas will strike us, but because something else could. The comfort of this moment lies in probability. The unease lies in inevitability. Somewhere, someday, the counterfactual will step out of imagination into reality. The only question is which form it will take and whether we will be ready to meet it. Every chain of reasoning eventually encounters its own limits, and with 3i Atlas, the most compelling boundary is paradox itself. We can say with confidence that the sun cannot be endangered by such a small interstellar object, yet the spectacle of its approach toward that blazing star ignites a feeling of tension that logic cannot fully extinguish. The paradox rests in the clash between scale and perception. How can something so insignificant stir emotions of such magnitude? On one side stands the immensity of the sun. Its nuclear heart fuses 600 million tons of hydrogen into helium every second. Its magnetic fields twist and snap in eruptions that dwarf our planet. Against that scale, Atlas is a moat. If it were to plunge directly into the solar surface, its energy release would be swallowed instantly. indistinguishable from the churning plasma already there. The Sun has absorbed bodies larger than Atlas countless times throughout its 4.5 billion-year existence, and nothing has altered its steady burn. The paradox is clear. The Sun cannot be threatened, yet we feel compelled to ask whether it might be. On the other side lies the human imagination, finely tuned not to astrophysical scales, but to metaphors of fire, collision, and fragility. A single spark in a dry forest can cause devastation. Why not a single object in a sea of flame? The same cognitive reflex that makes us flinch from a falling ember makes us uneasy when a cosmic ember arcs toward the star that sustains us. Thus, the paradox widens. Our intellect dismisses danger while our instincts amplify it. Another version of the paradox comes from our desire for permanence in a universe of impermanence. We know that the Sun itself is mortal. In billions of years it will exhaust its fuel, swell into a red giant, and ultimately shed its outer layers. That fate is inevitable. Yet the approach of a mere rock provokes greater unease than the certain knowledge of stellar death. Why? Because the rock is immediate, an intrusion in our present, whereas the Sun's demise resides safely in the distant future. Here the paradox deepens. The remote catastrophe is certain, the present one is negligible, but our emotions reverse the scale of concern. There is also the paradox of knowledge. Interstellar objects like Atlas are rare windows into alien chemistry, and scientists long for them to come close enough to study in detail. Yet proximity to the Sun, the very condition that makes their sublimation observable, also guarantees their destruction. The closer Atlas drifts, the more information it offers, until it is gone forever. Knowledge grows in inverse proportion to the object's survival. We can either watch it vanish into fire or wish it had remained invisible in the dark. Both options leave us dissatisfied. And then there is the paradox of belonging. Atlas is not native to our solar system. It is a stranger passing through. Its foreignness is what makes it valuable, yet once it is here, it becomes part of our story. We classify it, track it, narrate its journey. In doing so, we claim it as ours, even as we know it will depart again. We want to own the encounter, though ownership is impossible. The paradox is one of intimacy with the unattainable. Such paradoxes are not flaws in reasoning, but invitations to linger at the edges of comprehension. They remind us that science does not erase mystery. It often heightens it. Each attempt to explain Atlas's insignificance only intensifies the emotional resonance of its approach. Each reassurance that the Sun is safe throws into relief the uncanny feeling that we are not. These contradictions extend beyond astronomy into the human condition itself. We crave certainty, but thrive on wonder. We seek safety, but are drawn to danger. We dismiss small risks, but obsess over them. Atlas embodies these contradictions in motion, a cosmic riddle that reflects our own paradoxical nature. And yet, paradox does not end in paralysis. It propels thought forward, forcing us to ask new kinds of questions. If the Sun cannot be harmed, why does the idea of harm feel so plausible? If knowledge requires loss, how do we value what disappears? If something foreign becomes ours for a moment, what does that say about the boundaries of identity, cosmic or human? These questions may not yield clean answers, but they keep the inquiry alive. As Atlas edges closer to its moment of maximum encounter, the paradox only sharpens. We know too much to treat it as a myth and too little to strip it of mystery. In that tension lies the essence of engagement, the certainty that logic and awe will continue to wrestle, neither quite defeating the other, each amplifying the other's power. And from that wrestling match emerges the next step, grounding the paradox in the familiar, pulling the immensity of cosmic contradiction down into the scale of everyday life. For all the grandeur of astrophysics, the human mind insists on tethering vast events to the scale of daily experience. We can speak of hyperbolic trajectories, stellar gravity, or isotopic ratios, but without translation into familiar frames, the facts float untethered. The approach of 3i Atlas toward the Sun may sound distant and abstract until we search for analogies that bind it to what we already know. Only then does it begin to feel real, not just as a headline or a graph, but as a phenomenon with echoes in the rhythm of our own lives. Think of ice left on a warm kitchen counter. At first, it glistens silently, almost imperceptibly changing. Then cracks form. Beads of water trickle. Steam might rise if heat is intense. What was once solid becomes volatile. In essence, that is what happens when an interstellar object ventures too near to a star. The physics is the same, scaled up to unimaginable degrees. Solid ices shift straight into gas, carrying dust along, reshaping the object's form. By recalling the melting of an ice cube, we grasp the drama of Atlas's disintegration without needing to picture nuclear furnaces or orbital mechanics. Or take the experience of standing by a bonfire on a cold night. As you draw near, the heat grows unbearable. Step back and the air cools. The distance makes all the difference. So it is with Atlas. For eons, it drifted in the interstellar cold, undisturbed, inert. Now, approaching the Sun, it finds itself in a blaze it cannot endure. In our bones, we understand this. Approach too close to the source of heat, and you pay a price. Another link emerges in the psychology of the unexpected guest. Imagine your home as orderly, routines predictable, every item belonging. Then one day a stranger appears at the threshold, uninvited. They may not intend harm, but their presence changes everything. Attention shifts, questions arise, the ordinary feels unsettled. This is how the solar system feels to us when Atlas enters. The planets, moons, and comets are family. We know their habits. An interstellar object is the stranger, unfamiliar and intriguing. Its very presence alters the mood of the household. Daily life also teaches us about perspective on risk. A pebble thrown into a river barely disturbs the flow, yet to a fish swimming nearby, the ripple may be dramatic. To the Sun, Atlas is the pebble. To us, observing from the shores of Earth, the ripple feels momentous. The lesson is simple but profound. Scale determines consequence, but human concern does not always scale accordingly. We are prone to amplify what feels immediate, even if it is cosmically trivial. Perhaps the most intimate connection comes through the idea of fragility. We know what it means for objects to break under stress, a glass shattering on the floor, a phone screen cracking, a balloon bursting in sunlight. These are everyday events, yet each mirrors what is happening to Atlas as it nears the Sun. Stress builds, integrity falters, fragments scatter. The cosmos, it turns out, is not alien in this respect. It obeys the same patterns we witness in miniature all around us. There is comfort in these parallels. They reassure us that the universe is not incomprehensible, only vast. The same principles that govern a melting ice cube or a shattering glass also govern the fate of interstellar wanderers. What changes is only the scale, not the essence. To ground the cosmic in the ordinary is to reclaim a sense of participation in events otherwise too remote to matter. And yet, there is also unease in the comparison. If Atlas is fragile like our belongings, might we too be fragile like Atlas? When we see it disintegrating under solar heat, we cannot help but glimpse our own vulnerability under the stresses of time, environment, and chance. The everyday analogy circles back not to the Sun, but to ourselves. The cosmic drama reflects our private fragilities. This mirroring effect, the Sun's heat-breaking Atlas as daily heat breaks our ice or glass, cements the importance of connecting astrophysics with lived experience. Without such grounding, Atlas remains a curiosity in the abstract. With it, Atlas becomes a parable of limits, of distance, of the difference between resilience and collapse. The connections do not end in comfort or fear. They create a bridge. By understanding Atlas through the lens of our own lives, we prepare ourselves to reverse the perspective and see our lives through the lens of Atlas. If the everyday can explain the cosmic, perhaps the cosmic can explain the everyday. That reversal leads directly into a deeper dive into the mechanisms at work, the physical processes that strip mystery from spectacle while preserving its power to astonish. To move beyond analogy, we must examine the engine that drives the entire spectacle, the physical mechanism by which an interstellar object like 3I Atlas interacts with the Sun. This is not simply a story of heat and fragility. It is a story of physics in its most elemental form, where energy, matter, and motion collide. By understanding this mechanism, we can see clearly why Atlas will not threaten the Sun, while simultaneously appreciating why it will transform so dramatically in the days of its closest approach. The key process is sublimation. Unlike melting, in which a solid becomes a liquid before vaporizing, sublimation skips the middle step. When ice is locked in Atlas's crust, water, carbon dioxide, carbon monoxide, perhaps more exotic compounds, absorb enough solar energy, they leap directly into the gaseous state. On the surface of Earth, sublimation is rare and requires special conditions. In the vacuum of space, it is common, even inevitable. With no atmosphere to buffer the process, molecules vibrate faster under sunlight until they break free entirely. Each escaping molecule carries momentum, producing a jet that pushes back against the object. This is where the mechanism becomes fascinating. The jets are not evenly distributed. Some regions of Atlas may be covered in insulating dust, while others expose volatile, rich ice. When one patch outgasses more vigorously than another, the escaping molecules act like miniature thrusters. They nudge the object, altering its trajectory in tiny but measurable ways. Astronomers call this non-gravitational acceleration, and it has already been observed in other comets. In the case of Oumuamua, the effect was puzzling enough to spark speculation about artificial propulsion. With Atlas, these jets are expected, but their precise pattern will reveal much about its composition and structure. Meanwhile, the Sun's radiation does more than trigger sublimation. Photons themselves exert pressure. Though minuscule, the constant bombardment of light across millions of kilometers adds up, subtly shifting dust grains shed by Atlas into long tails. These tails are not random plumes, but structured flows, bent by the balance of solar gravity and radiation pressure. What we see as a luminous streak in the sky is in fact a dynamic laboratory of forces, each particle tracing the invisible vectors of energy exchange. Thermal stress compounds the effect. As one side of Atlas bakes while the other lingers in shadow, temperature gradients rise. Rock and ice expand and contract at different rates. Fissures open, surfaces fracture, chunks break away. Sometimes the process is gradual, shedding a mist of particles. Sometimes it is catastrophic, splitting the body into fragments that fly apart. In either case, the outcome is the same. Atlas is consumed by the very star it approaches. Electromagnetic forces add another layer. The charged particles streaming outward from the Sun, the solar wind, collide with the gas released by Atlas, ionizing it and dragging it into vast, ghostly tails that can stretch millions of kilometers. These plasma tails are not passive. They shimmer, twist, and disconnect in response to solar storms. To study them is to study the Sun itself, for the interaction serves as a visible tracer of solar wind dynamics. In this sense, Atlas does not merely reveal itself near the Sun, it reveals the Sun's hidden weather. Each mechanism interlocks with the others, producing a cascade of outcomes. Sublimation drives jets. Jets alter motion. Motion changes how sunlight falls on the surface. New fractures open, more sublimation occurs. It is a feedback loop that accelerates as the object draws closer to the furnace. The process is both destructive and revelatory, annihilating the object while broadcasting its secrets. What makes this mechanism so compelling is not its novelty. Scientists have studied comets for centuries, but its context. Atlas is not local. Its ices and dust are not of this sun, but of another. The sublimation jets may carry ratios of hydrogen to deuterium that differ from those found in Earth's water. The plasma tails may bear isotopic fingerprints of environments billions of years and trillions of kilometers away. Each molecule released is a message from an alien cradle. Yet here lies the quiet tension. We cannot control the pace of revelation. The sun dictates it. If Atlas disintegrates too quickly, the story ends in a blur. If it holds together longer than expected, we gain more data. The mechanism is inexorable, but its timeline is uncertain. It is as though we are reading a book whose pages are burning even as we turn them. Understanding this mechanism strips away the illusion of cosmic drama while replacing it with something more profound. Awe at the precision of physics. Nothing mystical is needed to explain why Atlas will vanish. The laws of thermodynamics and celestial mechanics are enough. But to see those laws in action, to watch a body older than our species unravel under their governance, is to feel the raw clarity of science as spectacle. Still, knowledge of mechanism does not quiet the larger curiosity. If we can see so much from this one encounter, what might we learn from others? And if these processes play out for every interstellar fragment, what cumulative influence might they have on the solar system's history? To explore these questions requires not only understanding the mechanism, but also examining the methods by which scientists extract truth from fleeting events, turning sublimation jets and dust tails into data that can outlast the visitor itself. When a phenomenon is fleeting, the methods used to study it must be both urgent and ingenious. 3I. Atlas offers only a brief window of opportunity, months, perhaps a year at most, before it either fades into the distance or disintegrates near the sun. Unlike planets that remain under constant observation, or comets that cycle back on predictable timescales, an interstellar object is a one-time chance. Once gone, it will never return. This urgency shapes every decision scientists make, from the choice of instruments to the strategies of collaboration. The first step is detection itself. Atlas was discovered by survey telescopes scanning the sky for transient objects. These surveys are designed to catalogue asteroids that might pose risks to Earth, but their wide fields of view and automated image processing pipelines also flag anomalies, moving points of light that don't fit known catalogues. Once Atlas was spotted, astronomers rushed to calculate its trajectory. The mathematics of orbital determination is precise but demanding. A handful of early observations can reveal whether an object is bound to the sun or is merely passing through. The hyperbolic curve of Atlas's orbit gave away its interstellar origin almost immediately, transforming it from just another dot on a CCD into a cosmic event. After detection comes characterization. Observatories across the globe pointed at the newcomer, using optical telescopes to measure brightness and spectra. Brightness tells us about size and reflectivity. Spectra tell us about composition. The challenge is that Atlas is faint, often barely distinguishable from background noise. To extract data, astronomers must carefully subtract the interference of starlight, atmospheric distortion, and instrument quirks. Each data point is precious, each photon a messenger from another system. But no single telescope is sufficient. Interstellar objects demand coordination on a planetary scale. Observatories in different hemispheres trade schedules. Radio telescopes join in to measure outgassing. space-based observatories like Hubble or the James Webb Space Telescope offer views beyond the blur of Earth's atmosphere. The methods are distributed, but the goal is singular: to catch as many angles as possible before the object slips away. Ground-based spectroscopy reveals what gases Atlas might emit as it heats. Are there traces of cyanogen, carbon monoxide, water vapor? These signatures tell us about the chemistry of its birthplace. Infrared observations dig deeper, detecting thermal emission that reveals surface temperature and grain size. Radar, though harder to employ for such distant bodies, can map shape and spin if the geometry allows. Even amateur astronomers with modest equipment contribute by tracking brightness variations, filling in gaps that professional observatories cannot always cover. In parallel, theoretical work races ahead. Dynamical simulations model the object's trajectory, not only under gravitational forces, but also under the subtle push of sublimation jets. These models predict where Atlas will be on any given night, guiding telescopes to aim in the right place. Computational chemists model how its ices should behave under solar heating, comparing predictions to real-time spectral data. The scientific method here is not linear, but braided. Observation feeds theory, which feeds new observation, in a feedback loop as dynamic as the object itself. One striking feature of such research is the culture of openness. Because time is short, secrecy serves no one. Data are shared rapidly, often in real time, through circulars and online repositories. Teams that normally compete for telescope time cooperate, aware that the universe will not wait for their rivalries to resolve. In this way, the passage of an interstellar object creates not just scientific data, but also social transformation, a brief suspension of competition in favor of collective urgency. And still, limits press in. Instruments cannot capture everything. Observing time is finite, weather intervenes, detectors have thresholds. The methods are powerful but imperfect. Scientists are forced to triage, deciding which questions are most essential. Is composition more important than spin state? Should resources go to spectroscopy or photometry? Each choice shapes the archive of knowledge we will carry forward once Atlas is gone. Beyond observation, there is speculation about future missions. Had we known of Atlas sooner, could we have launched a spacecraft to intercept it? The answer is sobering. With current technology, probably not. Interstellar visitors are discovered too late and move too quickly, but the thought itself spurs proposals. Fast response probes waiting in readiness, solar sails capable of high acceleration, even swarms of small spacecraft dispatched at a moment's notice. The methods we use now are observational. The methods we dream of involve direct encounter. Atlas, by eluding our grasp, pushes us to design for the next opportunity. What emerges from all this is a portrait of science in motion. It is not the steady accumulation of facts, but the improvisation of a community responding to a fleeting phenomenon. The methods are diverse, but the rhythm is the same. Detect, characterize, interpret, share, speculate. Each step is infused with urgency, for the clock is always ticking. And yet, even as methods sharpen our understanding, they do not settle the story. Observations can be interpreted in more than one way, data can be read through different lenses, and uncertainty always lingers. Which means that after the flurry of detection and analysis, another stage begins. The exploration of alternative interpretations, the branching pathways of meaning that even the best methods cannot fully close. The data begin to accumulate, light curves, spectral lines, velocity measurements, yet as soon as they are gathered, the interpretations diverge. This is the nature of astronomy, and especially of objects as rare and alien as 3I Atlas. Each fragment of evidence can be read in more than one way, and the uncertainty becomes fertile ground for competing narratives. These alternatives are not idle speculation, but serious attempts to extract meaning from an object that refuses to settle into a single category. One line of interpretation emphasizes continuity. Atlas as nothing more than a comet from elsewhere, behaving like any other comet we have studied. In this view, the fact that it comes from interstellar space matters less than the fact that its physics conforms to expectation. The jets of gas are typical, the brightening curve familiar, the path toward disintegration unsurprising. To see Atlas as ordinary is to affirm that the laws of nature hold universally. Wherever in the galaxy icy fragments are born, they will act the same way when exposed to a star's heat. This reading offers comfort, a reminder that the cosmos is not fundamentally strange. Yet another school of thought stresses anomaly. To some researchers, Atlas is not behaving exactly like our comets. Perhaps its albedo is unusual, or its outgassing composition defies local patterns. Even tiny deviations become significant because they hint at environments we have never directly sampled. If the ratios of carbon monoxide to water are skewed, perhaps Atlas formed farther from its original star than our comets did. If its dust grains scatter light oddly, perhaps its home system underwent a different chemical evolution. Under this interpretation, Atlas is not just another comet, but a messenger from an unfamiliar laboratory of creation. There is also the interpretive frame of symbolism. For centuries, comets were read as omens, signs of upheaval or change. While modern science dismisses such superstition, traces of it linger in cultural reaction. To some, Atlas's approach toward the sun evokes mythic narratives, Icarus flying too close or sacrifices offered to fiery gods. These interpretations may not belong in scientific journals, yet they shape how the public perceives the event. And public perception, in turn, influences funding, policy, and the broader cultural meaning attached to the data. Science cannot isolate itself completely from symbolism. Even the name Atlas carries mythic weight. A more radical interpretation arises from the precedent of Oumuamua. That earlier interstellar visitor defied easy categorization. With its cigar-like shape and odd acceleration, some prominent scientists even suggested it could be artificial, a probe or fragment of alien engineering. Though most astronomers favor natural explanations, the debate lingers in memory. When Atlas appeared, some could not resist asking, could this one also be something more than natural? The mainstream answer is no. Its behavior is cometary, not anomalous. Yet the shadow of alternative possibility remains, a reminder of how quickly science fiction can seep into science when the unknown intrudes. Another interpretive path focuses less on the object itself and more on the system it came from. By measuring isotopic ratios, scientists can infer the temperature and density of the protoplanetary disk in which Atlas formed. Was it a system richer in volatiles than ours? Did its star emit more ultraviolet radiation, shaping different chemistry? In this reading, Atlas is not the story, its birthplace is. The object becomes a clue, a sample in a cosmic detective case, and the true focus is the distant star whose identity we may never know. And finally, there is the pragmatic interpretation, Atlas as rehearsal. In this view, it matters less what Atlas is in itself and more what we learn about how to respond to such encounters. Every telescope pointed at it, every collaboration formed, every model tested. These are exercises that prepare us for the next interstellar visitor. Atlas, then, is not an end, but a beginning, a training ground for future opportunities. These divergent interpretations coexist, not because scientists are confused, but because the evidence allows multiple readings. Each emphasizes a different facet: universality, anomaly, symbolism, speculation, origin, or rehearsal. None cancels the others, and together they reveal the richness of an event that might otherwise seem simple. Atlas is a rock and a riddle, a comet and a question, a data point and a myth. The plurality of interpretations reflects a deeper truth. Science thrives not on consensus alone, but on the tension between competing views. Certainty will come slowly, if at all. Until then, Atlas functions as a mirror, reflecting back the assumptions we bring to it. Are we inclined to see order, or mystery, or message, or omen? The choice says as much about us as it does about the object itself. But while interpretations multiply in the present, another dimension stretches out behind them: time. To grasp the full weight of Atlas's passage, we must consider not only what it means now, but how such encounters fit into the long arc of cosmic evolution. Only then can we see how extraordinary this fleeting moment really is. Time is the hidden dimension in which the drama of 3i Atlas truly unfolds. At first glance, its arrival feels like a sudden intrusion, a surprise discovery framed by the urgency of present observation. But in truth, its story stretches across scales of time so vast that our immediate moment is only the briefest flash in a chain billions of years long. To understand what it means for Atlas to approach the Sun, we must place it within that temporal landscape. Begin at the farthest edge, the birth of stars. Roughly 5 billion years ago, long before Earth solidified or life stirred in oceans, the gas and dust of our solar nebula collapsed under gravity to form the Sun. Elsewhere in the galaxy, similar processes unfolded. Around one of those other newborn stars, Atlas formed. Perhaps it coalesced as part of a planetesimal belt, perhaps as a shard from an early collision. For eons, it orbited its parent star, locked in the stable rhythm of its native system. Then through a chance gravitational encounter, maybe with a migrating giant planet, maybe with a passing star, it was ejected. That moment severed its connection, exiling it to drift across interstellar space. For millions, perhaps hundreds of millions of years, it traveled alone. The galaxy is not empty, but its distances are so immense that encounters are rare. In the silence between stars, Atlas endured temperatures near absolute zero, its chemistry frozen in time. While civilizations on Earth rose and fell, while continents split and oceans shifted, Atlas continued its solitary path. The immensity of its journey dwarfs the entire span of human history. Only recently, on astronomical scales measured in decades, did Atlas cross the threshold of our solar system. The Sun's gravity, faint but far-reaching, curved its path inward. The moment we observe now is the culmination of epochs of motion, a brief intersection between its trajectory and our attention. For us, it is an event of months. For Atlas, it is a single heartbeat in a life measured in billions of years. This temporal perspective shifts the meaning of its approach to the Sun. Rather than a sudden confrontation, it is the inevitable conclusion of a long story. The Sun is not a threat to Atlas, but a terminus, a destination written into its course by the physics of chance encounters long ago. Its disintegration will not be an accident, but the natural end of a journey set in motion before Earth's biosphere had even taken shape. Time also offers perspective on the rarity of our vantage. Interstellar visitors like Atlas are statistically expected, but their arrival within a human lifespan is extraordinary. For centuries, astronomers scanned the skies without ever confirming one. Then within a span of just a few years, 3 appeared: Oumuamua, Borisov, and Atlas. This clustering may be coincidence, or it may reflect the sharpening of our instruments and surveys. Either way, it reminds us that human time and cosmic time sometimes overlap in startling ways. Our lifetimes, brief as they are, can intersect with stories that began billions of years earlier. Looking forward, time reframes the question of significance. Atlas will soon be gone, fading back into the dark or breaking apart near the Sun. Yet the data we collect will remain, archived in papers, stored in digital records, transmitted through generations of researchers. Its physical presence will vanish, but its informational trace will persist, woven into the cumulative knowledge of humanity. In this way, its passage will extend beyond itself, influencing ideas and models for decades, maybe centuries to come. But the temporal arc stretches even further. The Sun, indifferent to Atlas, continues its own life cycle. In 5 billion years, it will expand into a red giant, consuming the inner planets. Long after Atlas has disintegrated, the Sun itself will perish, leaving behind a white dwarf. From that perspective, Atlas's visit is a brief flicker in a story whose true climax lies far ahead. Yet paradoxically, it is our brief window of consciousness that makes the flicker meaningful. Without us to see it, the event would pass unnoticed, just another whisper of dust into fire. This tension between the vastness of cosmic time and the brevity of human observation underscores why Atlas matters. Its presence reminds us that the galaxy is alive with motion, that histories older than our world intersect with our present. It shows that while our lifespan is short, it is long enough to catch glimpses of eternity passing by. And perhaps most provocatively, time asks us to imagine futures in which such encounters are no longer accidents but choices. If humanity survives long enough, will we one day launch missions, not just to observe interstellar objects, but to intercept them, mine them, even redirect them? Time opens these possibilities, stretching the relevance of Atlas far beyond its brief appearance now. For the moment, though, we are suspended in this intersection, the long journey of Atlas converging with the short attention of human beings. From this meeting emerges a rare chance to construct meaning, and to press the exercise further, we can take time as more than history. We can use it as imagination. What happens if we project forward, not with prediction but with experiment, letting thought trace the possibilities of Atlas's fate and our own? Suppose for a moment we set aside the data, the measured curves and spectra, and step into the laboratory of thought. A thought experiment does not claim reality. It stages possibilities, stripping away noise to illuminate structure. With 3i Atlas approaching the Sun, such an experiment allows us to probe consequences beyond what we can witness directly, testing the boundaries of imagination against the scaffolding of physical law. Imagine Atlas resisting disintegration. Picture it hardened, composed not of fragile ices, but of dense refractory minerals. As it sweeps close to the Sun, instead of blossoming into a tail, it endures. The solar heat scours its surface but fails to shatter it. It dives past perihelion, slingshotting around the star, and then accelerates outward into the dark. What would this mean? For scientists, it would be both disappointment and wonder. Disappointment because the lack of outgassing robs us of spectral data. Wonder because such resilience would imply a birthplace radically different from cometary belts as we know them. A body that can brush the Sun and survive must have formed in a furnace-like environment under pressures and temperatures alien to our expectations. Now reverse the premise. Suppose Atlas is more fragile than anticipated, its internal structure riddled with voids, a loose rubble pile rather than a solid nucleus. Long before reaching perihelion, even as it crosses Mars's orbit, it shatters into a cloud of fragments. The pieces scatter, each tracing its own path, some spiraling inward, some drifting outward. To Earth-bound telescopes, the event looks like a sudden flare, a brightening followed by rapid dissipation. Such a scenario would highlight the unpredictability of interstellar visitors. It would show that not all obey the patterns we expect from local comets. It might even deprive us of meaningful data, leaving only questions in the wake of spectacle. A third scenario pushes further. Imagine that as Atlas approaches, its jets of sublimating gas are not random, but asymmetric enough to create sustained acceleration. The object begins to drift in ways gravity alone cannot explain. Astronomers notice deviations from predicted paths. Speculation rises. Is this another Oumuamua, a body whose behavior hints at propulsion? In this thought experiment, Atlas becomes a test case in humility. Even if natural explanations suffice, jets, mass distribution, shape, the mere possibility of alternative interpretations forces us to reconsider the boundaries of what we accept as natural. Or take a more anthropocentric thought. Suppose Earth did cross the trail of Atlas's dust. The fragments would not be catastrophic, but they might produce a spectacular meteor storm, lighting the skies for nights on end. Millions would watch, inspired, unsettled, transformed. The object itself would never touch Earth, yet its legacy would be etched into memory through fire in the sky. Here the experiment demonstrates how even harmless cosmic debris can profoundly alter culture, shifting how people imagine their place in the universe. One could even stretch the thought experiment into philosophy. Imagine that Atlas is not a rock, but a messenger, not in the sense of alien design, but as a symbol of connectedness. A fragment formed in one stellar nursery finds its way into another, crossing gulfs of space to dissolve in light we depend on. Is that not a story of cosmic kinship? The experiment becomes less about physical outcome than about meaning. What does it signify for us that material from a distant star can meet its end in ours? The power of thought experiments lies not in accuracy, but in illumination. They allow us to see Atlas not as a static object, but as a node in a network of possibilities. Each scenario highlights a different aspect of significance. Resilience speaks to planetary formation, fragility to structural diversity, acceleration to interpretive caution, meteor showers to cultural impact, symbolism to existential reflection. Reality may select only one path, but imagination rehearses them all. And yet, thought experiments also sharpen the contrast between what is possible and what is actual. We may picture Atlas surviving its encounter, but the physics of sublimation makes its disintegration far more likely. We may envision meteor storms, but orbital mechanics suggest Earth will remain clear of its debris. The imaginative exercise thus rebounds into clarity. By exaggerating the alternatives, we grasp the solidity of the real. Still, the exercise leaves behind a residue of curiosity. If so many scenarios are conceivable, how much do we truly know about interstellar objects? Oumuamua surprised us. Borisov behaved more predictably. Atlas charts a middle path. Each thought experiment reflects uncertainty as much as knowledge, which leads naturally to the next step, moving from speculation to assessment, from imagining what might happen to clarifying what we currently understand. For if thought experiments sharpen questions, only the state of knowledge can attempt to answer them, however provisionally. The current state of knowledge about 3I Atlas is both richer than it might seem and thinner than we would like. Richer because in only a short time astronomers have extracted an extraordinary amount of information from faint photons. Thinner because so much of the object remains unknowable, either hidden in distance or erased by its own disintegration. To speak of what we know is to balance detail against humility. We know its path. Orbital calculations are among the most reliable tools in astronomy. With a series of observations spaced over days, scientists can determine whether an object's motion is closed and elliptical or open and hyperbolic. In Atlas's case, the verdict is hyperbolic, and the excess velocity ensures that it is not bound to the Sun. This is the third time humanity has confirmed such an orbit, joining Oumuamua and Borisov in the short catalogue of interstellar visitors. The trajectory also tells us that Atlas will not linger. It is inbound now, soon to curve around the Sun and then outbound forever. That fact alone is secure. We know its brightness profile. Careful photometry tracks how Atlas reflects sunlight and how that reflection changes over time. These measurements reveal that it is not static, its activity increases as it warms. The light curve shows irregularities, suggesting jets of outgassing and perhaps a rotation period that causes the visible area to shift. From brightness alone, astronomers estimate its size, though uncertainties remain. Is it a few hundred meters, a kilometer, more? Reflectivity or albedo complicates the picture. A dark surface would imply a larger body, a shiny surface, a smaller one. Thus, even here, knowledge is conditional. We know fragments of its chemistry. Spectroscopy reveals lines consistent with volatiles like water, carbon dioxide, and cyanogen. These are common in comets, but the ratios matter. Early data hint at differences compared with local populations, though uncertainties are wide. If confirmed, those differences would suggest that Atlas formed under conditions distinct from those of our own solar system. Already, even with incomplete evidence, the object whispers of alien chemistry, a material fingerprint of another cradle of planets. We know its context. Interstellar visitors are expected by theory. Models of planetary system formation predict that vast numbers of icy bodies are ejected during early gravitational shuffling. Most wander in darkness, invisible, but some cross paths with stars like ours. The fact that we have now seen 3 in a handful of years is less a surprise than a confirmation. The galaxy is strewn with such debris, and improved surveys are finally revealing them. Atlas, then, is not an anomaly, but a data point in a broader population. What we do not know is equally instructive. We do not know its precise size or shape. Radar observations have been too limited, and brightness variations too ambiguous to fix its form. It could be elongated like Oumuamua or more spherical. The data allow multiple fits. We do not know its interior structure. Is it monolithic or a loose rubble pile? Density estimates depend on assumptions about albedo and outgassing, leaving large margins. We do not know its exact place of origin. Trajectory analysis can point backward, but once beyond the sun's sphere of influence, uncertainties expand into vast volumes of space. The best we can say is that it came from elsewhere, likely ejected long ago from a system we may never identify. And we do not know how it will end. Will it disintegrate completely near perihelion, scattering into dust invisible to all but the most sensitive instruments? Will it survive as a remnant core, dim but intact, sailing outward into interstellar darkness once again? Observations can constrain probabilities, but certainty awaits only the unfolding of time. This blend of knowledge and ignorance is characteristic of frontier science. Each fact is paired with a gap, each answer with a question. Yet even this partial knowledge reshapes our sense of place. We now know that our solar system is porous, not sealed. We know that material from distant stars can cross our path. We know that the chemistry of other worlds can be glimpsed in a passing fragment. And we know that our tools are capable of extracting meaning from the faintest of signals. Atlas, in this light, is not merely a curiosity, it is evidence. Evidence that the processes we infer about planetary formation are correct. Evidence that interstellar space is not sterile, but seeded with remnants. Evidence that humanity's eyes are sharp enough to catch a traveler across billions of kilometers. This is no small triumph. But knowledge is not static. It carries implications. To know that interstellar objects are real and frequent is to face the consequences of their presence. What practical meaning does it have for us that such bodies can appear at any time, on any trajectory, carrying unknown material into our neighborhood? The next step is to trace the implications of Atlas, to see how its passage might ripple outward into human affairs, technology, and the way we plan for our future under the sun. Knowledge never stays in the realm of abstraction for long. Once we know that 3i Atlas exists, that it is inbound, that it represents one of many such interstellar fragments moving silently through the galaxy, we cannot help but ask, what does this mean for us? Practical implications emerge almost immediately, some subtle, others profound, all woven into the ongoing conversation between science and society. The first implication is observational. Atlas demonstrates that our sky surveys are working. The algorithms scanning millions of pixels each night, the networks of telescopes passing alerts from one hemisphere to another. These systems are not just academic exercises, they are our planetary senses, and the discovery of Atlas proves that they can detect fleeting, faint visitors. The practical consequence is reinforcement. Governments and institutions now see the importance of funding such surveys. An interstellar object may not be a threat, but a local asteroid could be, and the infrastructure is the same. By catching Atlas, we rehearse for catching dangers closer to home. A second implication involves planetary defense. Even if Atlas itself poses no risk, its trajectory reminds us that not all inbound bodies are predictable. The solar system is open, porous. An interstellar fragment could, in principle, intersect Earth's orbit. The probability is low, but not zero. This realization fuels ongoing debates about preparedness, how to detect smaller objects earlier, how to design missions that could intercept or deflect them, how to coordinate international response. Atlas sharpens the stakes. Its harmlessness paradoxically increases urgency, because it shows that we live in a cosmic crossroads where encounters do happen. There are also implications for resource science. Interstellar material may contain compounds not easily found in our own backyard. If future technology allows interception, such bodies could become targets for mining or study. Imagine harvesting isotopes rare on Earth but common in another system, or analyzing organics that evolved under foreign starlight. Atlas itself will not yield such bounty, but its passage keeps the possibility alive. Practical imagination stretches forward. Space exploration as not only local, but interstellar in scope. Beyond technology, Atlas carries implications for culture and education. The mere announcement of its existence has already captured public attention. News headlines, classroom discussions, amateur astronomy networks all spring to life around such discoveries. The practical result is engagement. Children who might otherwise never think about astrophysics find themselves tracing orbits and imagining alien worlds. Funding agencies notice, curricula adjust, public science communication finds new footholds. In this way, Atlas becomes a tool of cultural investment in knowledge. Another practical thread is philosophical, but no less consequential. Knowing that debris from another star system has entered ours underscores the reality of interconnectedness. We are not an isolated island. Matter flows between systems. The dust in our lungs, the water in our oceans, the rock beneath our feet, all may contain atoms forged in distant stars. Atlas simply dramatizes that fact. The practical implication is subtle but powerful, a shift in worldview. Policymakers, educators, and citizens alike are reminded that Earth is part of a larger system, vulnerable to its flows, enriched by its exchanges. Even geopolitics is touched. Interstellar visitors are too rare and valuable for any one nation to monopolize. Observations must be shared. Data must cross borders. Atlas, like Borisov and Oumuamua before it, has spurred cooperation between institutions otherwise in competition. The practical consequence is precedent, a framework of collaboration that might extend to other space endeavors, from planetary defense to exploration. In a world fragmented by rivalry, an interstellar object becomes a rare incentive for unity. But not all implications are comfortable. There is also the risk of misinformation. Atlas's approach toward the sun invites sensationalism. Rumors of impending catastrophe, whispers of hidden knowledge, the allure of mystery twisted into fear. Scientists must therefore respond not only with data, but with narrative, explaining clearly why Atlas is fascinating but not dangerous. The practical task is communication, a challenge as real as orbital mechanics. Failure to meet it risks erosion of trust in science itself. The most far-reaching implication, however, lies in anticipation. Atlas is not the last. More will come, some larger, some smaller, some closer, some more distant. Each will bring opportunities and questions. Atlas teaches us that we must be ready, not in fear, but in readiness of attention. The next visitor may arrive when our instruments are sharper, our spacecraft faster, our society more coordinated. Atlas, then, is practiced not just for defense, but for discovery. Practical consequences ripple outward from a single faint object spotted against the stars. Some are immediate, like improved funding for sky surveys. Others are long-term, like reshaping how humanity thinks of its place in a galaxy of drifting fragments. All are real, and each prepares us to take the next step, to see Atlas not only as an isolated phenomenon, but as a point of intersection with other domains of knowledge. Domains that reach beyond astronomy into chemistry, biology, philosophy, even art. The question is not only what Atlas means for science, but what it means for everything else we know. Every scientific event has tendrils that extend far beyond its immediate field, and 3I Atlas is no exception. Though its path is traced in the language of astronomy, its significance radiates outward, touching disciplines as diverse as chemistry, biology, geology, and even the humanities. To see its passage clearly, we must trace these intersections and understand how a single interstellar visitor can echo across domains. Chemistry is the most direct crossing point. The gases and dust Atlas releases under solar heat are chemical records of its birth environment. If we detect ratios of water to carbon monoxide, different from those in our comets, we learn not only about Atlas, but about the universality of chemical processes in space. Are organic molecules abundant everywhere, or was our solar system unusually fertile? Atlas offers evidence. This is not idle curiosity. The chemistry of interstellar objects bears directly on astrobiology, the search for life beyond Earth. Molecules capable of supporting life may be seeded between systems by wanderers like Atlas. In this way, a comet's tail becomes a bridge between astronomy and the chemistry of life. Biology, too, finds relevance. The panspermia hypothesis, the idea that life, or at least its building blocks, can travel between stars on rocky fragments, has long been controversial. Atlas is not proof, but it is demonstration that fragments do cross between systems. If organic molecules are found in its outgassing, the idea of interstellar exchange of life's precursors gains plausibility. Even if no life is carried, the chemistry alone could have fertilized early worlds elsewhere. Thus, Atlas stands as a test case for one of the most profound questions biology can ask. How widespread are the seeds of life? Geology connects through material structure. Our comets and asteroids show a spectrum of densities, strengths, and fracture patterns. Atlas provides a data point from another system, a comparison that allows geologists to test whether planetary formation processes are universal. Do rubble piles exist everywhere? Are compact, monolithic bodies more common in some regions than others? These questions link the study of distant objects to the evolution of Earth itself, for our planet was built from similar fragments. Atlas carries echoes of planetary construction across the galaxy. Even climatology is indirectly touched. Dust and particles shed by interstellar visitors can, in theory, enter planetary atmospheres if orbits intersect. While Atlas will not influence Earth's climate, the concept matters. Interstellar debris may have played roles in the distant past, delivering exotic isotopes or triggering shifts in atmospheric chemistry. Geological layers on Earth already contain markers of extraterrestrial input, such as iridium from asteroid impacts. Atlas reminds us that such influences need not be local. Beyond science, the humanities engage. Philosophy sees in Atlas a challenge to parochialism. The object is alien, not in the sense of science fiction, but in the literal sense. It comes from another star. Its presence undermines the illusion of cosmic isolation. Ethics may ask, if one day we can intercept or exploit such bodies, do we treat them as resources to be mined or as heritage to be preserved? Literature and myth are stirred as well, for the name Atlas recalls burden and endurance, a titan holding up the sky. The act of falling toward the sun becomes a metaphor for human ambition and fragility. Art, too, finds inspiration. Images of interstellar comets streaking across the heavens feed the same creative impulses that have always accompanied astronomical discovery. Painters, poets, composers all find in such phenomena metaphors for exile, journey, and transformation. Atlas becomes not just an object of study, but a canvas for imagination. Technology, meanwhile, absorbs lessons. The inability to reach Atlas with spacecraft underscores the need for faster propulsion, for missions ready to launch on short notice. Advances in solar sails, nuclear propulsion, and rapid response engineering are spurred by such encounters. In this sense, Atlas intersects not only with disciplines of knowledge, but with disciplines of invention, shaping the tools that will carry humanity outward. Even politics and society are touched. The cooperative networks that spring up to track Atlas echo larger patterns of global challenge. Climate change, pandemics, and other crises also demand international coordination. The success of astronomers in sharing data swiftly across borders provides a model, small but illustrative, of how humanity might respond to problems that transcend nations. Atlas thus becomes a symbol of shared attention, a focus point for collective effort in an age of fragmentation. The intersections are everywhere. Chemistry of molecules, biology of life's origins, geology of planetary formation, climatology of atmospheres, philosophy of meaning, art of metaphor, technology of exploration, politics of cooperation. Each field absorbs something from the fleeting passage of an alien rock near our sun. The significance of Atlas lies not only in the photons it reflects, but in the ripples it sends across disciplines. But intersections also reveal boundaries. As ideas collide, we begin to ask where the limits of our models lie. How far can chemistry, biology, or astronomy stretch before they confront questions they cannot yet answer? How much of Atlas can be explained, and how much must remain unknown? To move forward, we must chart the borders of our knowledge as carefully as we chart the trajectory of the object itself. Boundaries are as important in science as breakthroughs. They mark the edge of what can be claimed with confidence, and they frame the territory where speculation must pause. With 3i Atlas, the limits of our models are as revealing as the discoveries themselves. To confront them is to acknowledge both the power and the fragility of knowledge. The first boundary is observational. No matter how many telescopes track Atlas, there are thresholds below which we cannot see. The object is faint, often barely brighter than the noise of the detectors. Even with the largest observatories, detail dissolves into approximation. We can infer size from brightness, but albedo introduces uncertainty. We can model rotation from light curves, but irregular shapes or outgassing skew the data. Radar signals strong enough to map local asteroids are too weak here. The result is a zone of ambiguity. We know Atlas exists, we know its trajectory, but its precise form remains elusive. Our instruments define the boundary of clarity. Another boundary is dynamical modeling. Orbital mechanics is exquisitely precise for planets and moons bound by gravity, but interstellar objects add complications. Non-gravitational accelerations caused by sublimation jets are notoriously hard to predict. Models can simulate them, but assumptions about surface composition and structure can lead to divergent outcomes. We can bracket probabilities, but certainty slips through our equations. The models are powerful, but not omnipotent. They describe trends, not guarantees. A third limit arises in chemistry. Spectroscopy gives us glimpses of molecular fingerprints, but only glimpses. The faintness of Atlas means that signal-to-noise ratios are low. Certain lines may be buried in uncertainty, others contaminated by Earth's atmosphere. Even when detection is clear, interpretation requires caution. A molecule present in trace amounts may appear absent. Another may masquerade under overlapping signatures. The chemical truth of Atlas is partially veiled, glimpsed through a narrow slit of light. Boundaries also appear in time. Atlas is fleeting. Unlike planets or even periodic comets, it offers only a short observational window. By the time models are refined and hypotheses sharpened, the object is already retreating, beyond reach of our instruments. Time itself sets the limit. There will be no second chance. We must learn within the span of a single passage, or not at all. There are conceptual boundaries as well. When Oumuamua was discovered, debate erupted over whether its anomalous acceleration might suggest artificial origin. The controversy revealed not only scientific disagreement, but philosophical limits. How far can we stretch natural explanations before considering extraordinary ones? At what point does caution turn into avoidance and imagination into overreach? Atlas is less anomalous than Oumuamua, but the memory of that debate lingers, showing how quickly interpretation can strain against conceptual walls. Another profound boundary lies in origin tracing. We can calculate where Atlas came from in broad terms. It arrived from interstellar space, but pinpointing its home system is beyond us. Gravitational perturbations along its path erase its trajectories past. Stellar motions over millions of years scramble the record. Even the best backward integration dissolves into uncertainty. Atlas will always remain rootless, its birthplace a mystery. This is a boundary not of technology, but of physics itself. The information has been lost in the chaos of galactic motion. Even imagination has limits. Thought experiments can conjure scenarios, but they cannot override the basic laws of probability. The counterfactuals we explored earlier remind us of what might have been, but not of what is. The boundary here is epistemic, the line between creative speculation and responsible inference. To cross it is to risk mistaking story for truth. These boundaries are not failures, they are coordinates of humility. They remind us that science is not omniscience, but disciplined ignorance. The edge of knowledge is where rigor matters most, where the temptation to claim more than we know must be resisted. Atlas, by being both visible and unknowable, forces us to confront these edges directly. Yet limits are not static. Observational boundaries shift with new telescopes. Dynamical models improve with new computing power. Chemical uncertainties shrink with better instruments. Even philosophical limits evolve as culture and science interact. Today's boundary may be tomorrow's foothold. Atlas exposes our current limits, but it also sketches the path forward. And that path leads naturally to the next stage, how these boundaries might be tested, pushed, and redrawn by future missions, technologies, and discoveries. For while Atlas itself will soon vanish, it leaves behind a challenge: to devise ways of probing the next interstellar visitor more deeply, and perhaps one day to meet such travelers not just with telescopes, but with machines sent to greet them. When an interstellar object passes through our solar system, the event is fleeting. The challenge is lasting. 3i Atlas will soon be gone, but its passage leaves us with a clear mandate: prepare for the next. If boundaries define the present, forecasts define the future. How might we test our limits, refine our tools, and position ourselves for the discoveries yet to come? The most immediate prospect is observational. With new facilities such as the Vera C. Rubin Observatory, equipped with the Legacy Survey of Space and Time, LSST, the sky will be watched with unprecedented depth and breadth. Rubin's nightly sweeps will capture faint, fast-moving objects that would otherwise slip through. Atlas, discovered only after it had already entered the inner solar system, demonstrates the need for earlier detection. Future surveys may find interstellar travelers years before they approach the Sun, giving scientists time to plan observations and perhaps even missions. Forecasts also focus on spacecraft readiness. At present, our missions are slow to mobilize. By the time an object like Atlas is detected, the opportunity for interception has passed, but concepts are emerging. Rapid response probes pre-positioned in space, solar sails capable of immense acceleration, nuclear electric propulsion systems designed for speed. NASA and ESA have both entertained studies of interstellar interceptors, missions that would lie dormant until triggered by the discovery of a target. In the coming decades, such readiness could transform the study of objects like Atlas, from remote observation to direct encounter. Predictions about frequency matter too. The first interstellar visitor, Oumuamua, was a shock. Borisov followed 2 years later, and Atlas not long after. Are we seeing a genuine uptick, or are our instruments simply sharper? Models suggest that billions of such bodies wander the galaxy. Their density in interstellar space implies that several should cross the solar system each year. Most are too small or faint to detect, but with new surveys, more will be catalogued. The forecast is clear. Atlas will not be the last. It is one of many, and the list will grow rapidly. Another frontier lies in laboratory preparation. By studying the signatures of exotic ices and minerals under simulated stellar conditions, chemists can prepare to interpret the spectral fingerprints of future visitors. When Atlas outgasses, its molecules appear as faint absorption lines. If we already know how to recognize unusual ratios or exotic compounds, we can decode those signatures more quickly. Forecasts in this sense are not predictions of events, but of readiness, creating libraries of possibilities before they arrive. There is also a cultural forecast. Each interstellar visitor ignites public imagination, feeding debates about life, origin, and destiny. As discoveries become more common, the shock may fade, but the curiosity will remain. Educational programs will likely seize on these events as teaching moments, while media will amplify them as symbols of cosmic connection. Future visitors may spark not only scientific papers, but novels, films, art movements. The forecast is not merely about data, but about meaning. The expectation that interstellar objects will become recurring motifs in the cultural landscape. Forecasts can extend into risk as well. While Atlas is harmless, the possibility exists, however small, that one day a larger interstellar body could intersect Earth's orbit. Planetary defense strategies must adapt to this scenario, however unlikely. Planning for impact mitigation cannot exclude interstellar trajectories. Already, the DART mission has demonstrated asteroid deflection on a local scale. Extrapolate forward, and one can imagine future planetary defense protocols accounting for objects like Atlas. Preparedness becomes planetary insurance. The most visionary forecasts stretch even further. If interstellar fragments carry chemical signatures of distant systems, then intercepting them may one day be our most practical way of studying alien planetary nurseries. Rather than sending probes to stars light years away, we could let their debris come to us, intercepting samples as they drift through. In this vision, every interstellar visitor is a free sample return mission from another star. The challenge is to catch them in time, but forecasts also warn of disappointment. Not every interstellar object will be spectacular. Many will be faint, undistinguished, lost in background noise. Some will resist classification, leaving us with more ambiguity than clarity. Expectations must be tempered with patience. The path ahead is not a steady climb of revelation, but a jagged terrain of surprises and frustrations. What unites all these forecasts is a sense of anticipation. Atlas is a messenger not only from another star, but from our own future, telling us that encounters like this will recur, that opportunities will multiply, that readiness will matter. It forces us to look beyond the fleeting glow of one visitor and imagine a time when interstellar fragments are routine subjects of study, when missions are launched not with desperation, but with design. And as we project forward, another realization grows. Each visitor, each forecast raises the stakes. The more we learn, the more urgent the questions become. Not about risk to the sun, but about the role of such encounters in reshaping our view of the galaxy and of ourselves. The stakes rise not in threat, but in meaning. And it is meaning, not danger, that turns the approach of Atlas into a matter of consequence. As 3I Atlas sweeps closer to the sun, the stakes begin to intensify, not because the star itself faces danger, but because of what hangs in the balance for us. The object is small, the sun is vast, yet the meaning of the encounter grows disproportionate to its scale. Every observation, every measurement, every fleeting photon captured by a telescope represents a chance to glimpse something irretrievable once Atlas departs. In this sense, the stakes are not physical, but epistemic. What we fail to learn now may never be learned at all. The urgency comes from rarity. Only 3 times have we confirmed interstellar visitors. Each time, the object appeared suddenly, leaving astronomers scrambling to repurpose instruments, reassign observation schedules, and secure precious telescope hours. The universe offers no warning, no repetition. Atlas is here once, then gone. This scarcity makes every lost opportunity sting. The stakes rise because the clock is ticking and the cosmos does not wait for our readiness. There is also the stake of narrative. Humanity thrives on stories, and Atlas is becoming part of ours. If we capture enough data, we can write a story of chemical diversity, of galactic exchange, of universal laws reflected in alien ice. If we fail, the story becomes one of missed chances, of mysteries glimpsed but not held. The difference matters. History will record whether we treated Atlas as a fleeting curiosity or as a milestone in our growing awareness of the galaxy's interconnectedness. Scientific stakes bleed into cultural stakes. A successful campaign of observation, with clear results published and shared, reinforces public trust in science. It shows that we can seize rare opportunities and turn them into knowledge for all. A muddled campaign, full of contradictions and uncertainties, risks feeding doubt, inviting sensationalism or conspiracy. Atlas, though physically harmless, is socially consequential. The stakes rise with each headline, each public debate, each classroom discussion that uses it as a teaching moment. The personal stakes for scientists are no less intense. Careers can hinge on discoveries tied to events like this. A graduate student who secures the first reliable spectrum of Atlas may see their work echoed for decades. A team that fails to interpret its dynamics correctly may find themselves remembered for errors. The pressure is immense, the window short. Stakes here are measured in professional futures as well as cosmic data. At another level, the stakes touch philosophy. Atlas forces us to confront the permeability of the solar system. It is not a closed bubble, it is open, intersected by fragments from elsewhere. This realization alters our conception of security. If alien matter can drift into our neighborhood, then the galaxy is less distant than we imagined. The stakes rise because our mental boundaries must shift, our sense of isolation evaporates, and with it, the comfort of separation. Then there is the broader stake of precedent. How we handle Atlas sets the tone for how we will respond to future visitors. If collaboration thrives, data flows openly, and insights are shared, we lay groundwork for a new era of cooperative science. If instead competition, secrecy or sensationalism dominate, the precedent will be damaging. The stakes are not just for this object, but for the culture of astronomy itself. Finally, there is the emotional stake. Atlas has become a mirror of our anxieties and aspirations. Its fall toward the sun evokes sacrifice, fragility, endurance, and loss. We watch it not only with telescopes but with imagination, seeing in its brief glow reflections of our own journey. The stakes here cannot be measured in data or policy, but in resonance, the way the event imprints itself on the collective psyche, altering how we feel about our place under the stars. All these stakes accumulate, layering urgency atop meaning. They do not signal disaster but significance, and significance, when pressed hard enough, reshapes perspective. The question is not only what we will learn from Atlas, but how we will frame it, how we will reinterpret its presence once the flare of its approach has passed. In that reframing lies the next stage, a shift of vision, a new optic through which the same event can be seen in an entirely different light. A shift in perspective can change everything. For weeks or months, the story of Three-Eye Atlas has been told through the lens of astronomy, a faint point of light plotted on charts, its orbit calculated, its chemistry inferred. Yet perspective is not fixed. By reframing the event, we discover layers of meaning invisible when viewed from only one angle. Atlas is not only a scientific object, it is also a mirror, a metaphor, a signal of how we perceive ourselves within the cosmos. Consider first the optic of scale. We usually place Atlas against the enormity of the sun, emphasizing its insignificance. But invert the comparison. Imagine Atlas not in relation to the sun, but to us. For human beings, its size, hundreds of meters, perhaps a kilometer, would be catastrophic if it struck Earth. In this reframing, Atlas is not negligible but immense. The sun shrinks into background. The object looms as a reminder of vulnerability. Same facts, different frame, radically different resonance, now shift to time. We often highlight the brevity of Atlas's visit, the narrow window of months before it vanishes. But what if we emphasize instead its longevity, the millions of years it drifted through interstellar space before entering our system? Suddenly, Atlas is not fleeting but enduring, a survivor carrying memory across the galaxy. Against its span, our civilizations are the fleeting ones, fragile bursts of consciousness in the blink of its journey. The optic of time reverses who is ephemeral and who is ancient. Another reframing comes through ecology. Atlas is not a threat or a guest, but a pollinator. Like a bee brushing past flowers, it carries dust and volatiles from one stellar system to another. In this view, the galaxy is a garden, and interstellar objects are its agents of cross-pollination. They enrich systems with foreign chemistry, spread organic molecules, and fertilize possibilities of life. Instead of menace or spectacle, Atlas becomes a gardener's tool, part of a larger web of galactic ecology. Reframing can also emerge from human history. Think of great voyages of exploration, Polynesian canoes crossing the Pacific, caravels probing the Atlantic. Atlas is another voyager, not bound by wind or sail, but by momentum and gravity. Seen this way, its approach to the sun is not a fall but a landfall, a moment of arrival at a strange shore. The sun is not a furnace, but a port, briefly hosting a traveler before it continues its endless journey. Such a lens transforms Atlas from a casualty into a navigator. Even myth provides an alternative optic. Named for the Titan condemned to hold up the sky, Atlas embodies endurance under burden. Its plunge toward the sun can be read as release, the end of a long wait carried across space. In this light, the event is not destruction, but liberation, an object finally freed of its load by dissolving into fire. Myth reframes physics into narrative, and narrative reshapes meaning. What these reframings reveal is that Atlas is not a fixed entity in our imagination. Its physical reality may be singular, but its interpretive potential is plural. Each lens, scale, time, ecology, history, myth, shifts the emphasis, drawing out different truths. None cancels the others, each enriches the whole. And there is power in that multiplicity. If Atlas can be framed as threat, as relic, as gardener, as voyager, as symbol, then it is more than an object, it is a prism. Through it we see not only alien matter but the flexibility of human thought. We discover that the meaning of an event depends less on what it is than on how we choose to see it. Yet reframing is not the end, it is a prelude. For once, perspectives have multiplied, emotions intensify. The event is no longer a faint smudge on a telescope image. It becomes a drama in which awe, fear, wonder, and urgency collide. And as Atlas nears its fiery encounter with the sun, this emotional crescendo becomes unavoidable. What has been reframed in thought now erupts in feeling, driving us toward a climax not of danger, but of resonance. Emotion has always shadowed reason, and with three-eye Atlas, the shadow grows brighter as it nears its end. Data and models can tell us what will happen, the heating, the outgassing, the fragmentation, but none of those equations capture the feeling of watching something older than our world plunge toward the sun. This is where the story tips into intensity, where analysis gives way to awe. There is first the feeling of loss. Atlas has traveled for millions, perhaps billions of years through the darkness between stars. It endured collisions, survived ejection, drifted in silence across gulfs so wide they reduce human history to irrelevance. And now, just as it enters our sight, just as we reach out to know it, it begins to die. Its fragments scatter into a luminous haze, its structure unravels, its history dissolves in light. We witness its passing not as tragedy, it is, after all, only rock and ice, but as a strange kind of elegy, a survivor from elsewhere, extinguished before us. There is also exhilaration. To see an interstellar visitor ignite against the backdrop of our own star is to feel connected to scales of time and space, usually inaccessible. We are small, but we are watching. We can measure the temperature of gases escaping from a body that once circled another sun. We can turn photons into knowledge, loss into understanding. That exhilaration is real, visceral, an echo of the first humans who looked up at comets and felt both fear and wonder. Atlas reignites that primal astonishment, tempered now with the sharpness of science. Then comes the unease. For while Atlas poses no threat, its spectacle reminds us of fragility. If this fragment had been shifted slightly in path, it might have intersected Earth. If it had been larger, it might have survived long enough to scatter debris across planetary orbits. Watching it disintegrate into sunlight forces us to imagine alternate worlds where such events reshape destinies. The unease is not fear of Atlas itself, but awareness of how thin the margins of safety are in a cosmos that is anything but orderly. Emotion crests higher still when we realize that we are witnesses at all. For countless ages, objects like Atlas have passed unnoticed, vanishing into stars without a trace. Only now, with our telescopes, our surveys, our fragile layer of global coordination, do we have the eyes to see. There is pride in that achievement, but also humility. To witness something so rare feels like a gift, but a gift we might easily miss. The emotion is gratitude sharpened by fragility. And finally, there is awe, pure and unfiltered. Awe at the thought of material forged around another sun meeting its end in ours. Awe at the physics so relentless, so exact, that it can turn exile into spectacle. Awe at the improbable convergence of our short lives with Atlas's long journey. Awe that we can even name it, track it, tell its story. Awe that the universe is so vast, and yet here, now, one of its wanderers falls into the center of our sky. All these emotions, Loss, exhilaration, unease, gratitude, awe, interweave, rising toward a crescendo. The object itself may vanish, but the resonance it leaves within us swells. Atlas becomes more than an interstellar body. It becomes a moment of emotional culmination, where human beings meet the cosmos not only with intellect, but with feeling. But culmination is not closure. Emotion crests into intensity, and then the question lingers. What remains when the light fades, when the dust disperses, when the memory cools? What finally do we carry forward from this encounter, and how does it alter the way we live under the sun? To find out, we must turn to the open ending, the unresolved chord that follows climax, a conclusion that is not an answer, but an invitation. When the blaze subsides and 3i Atlas dissolves into plasma and dust, what remains is not silence but resonance. A fragment of another star system has crossed our own, burned in our sun, and vanished. We are left with data, with images, with spectra to pass, but also with something less tangible, a set of questions that refuse to close. The thesis of this long encounter is simple enough. Atlas poses no danger to the sun. The scales are too mismatched. The star is unassailable by such a small wanderer. Yet as we have followed the object from discovery to disappearance, that reassurance has proved almost beside the point. The real weight of Atlas lies elsewhere, in what it reveals about the galaxy's openness, about our own fragility, about the way meaning emerges from cosmic chance. We know more now than we did at first glance. We know interstellar visitors are real and likely common, though rarely detected. We know our instruments are capable of catching them, if just barely. We know that even the smallest body can carry signatures of alien chemistry, traces of worlds we will never see directly. We know that the solar system is not an isolated stage, but a porous crossroad of galactic traffic. These are firm gains, knowledge solid enough to endure beyond Atlas's passing. And yet, alongside knowledge stands the open question. What does it mean to live in a galaxy where such encounters are inevitable? Does it change how we think about planetary defense, about the origins of life, about the possibility of communication across the stars? If Atlas is a messenger, what message does it bring? That we are not alone, or that the universe is indifferent, scattering fragments without purpose? There is also the question of readiness. Atlas arrived without warning, too fast and too late for any spacecraft to meet it. Next time, will we be prepared? Will we have interceptors waiting, missions poised to seize the opportunity, or will we again watch helplessly from afar? The question is technical, but also philosophical. How much effort do we devote to preparing for events that may never repeat in our lifetimes, yet matter on cosmic scales? And there is the question of meaning. When something ancient ends in our presence, what are we to feel? Relief that it brought no harm? Wonder that we glimpsed it at all? Regret that its secrets slip away faster than we can catch them? Atlas becomes a mirror, reflecting our own anxieties and aspirations, our longing for permanence in a universe defined by impermanence. So we are left with a paradoxical conclusion. Atlas is gone, yet its presence endures. It endures in data archived on servers, in models refined in journals, in metaphors woven into stories. It endures in the awareness that matter from alien suns can pass within reach of our instruments and our imaginations. It endures in the open questions that tug at us still. Should we be worried? About Atlas itself, no. The sun remains untouched, unthreatened, burning as it has for billions of years. But about what Atlas signifies, about the vulnerability of our planet, the fragility of our readiness, the openness of the cosmos, the worry is real, though it is better named vigilance. To witness Atlas is to be reminded that the universe is dynamic, porous, unpredictable, and that our place within it is contingent. The unresolved chord remains. We do not know when the next interstellar wanderer will come, nor what it will carry, nor whether we will meet it as spectators or as explorers. That uncertainty is not failure, but invitation. The sky will offer again, and again we will have to decide what to do with the fleeting gift. Atlas has passed, but the question lingers in its wake, unanswerable, yet urgent. In a universe alive with wanderers, how do we choose to live, watching from our fragile planet as strangers fall into the sun?